Hello everybody and welcome to another YouTube video. So in today's video, I'm going to share with you some topics that self-taught developers most likely will never learn. And when I say self-taught developer, I'm really talking about someone who hasn't gone through the traditional school system. And just to give you a bit of context here, I myself have done 2.5 years of a computer science degree. I've done most of the mandatory computer science courses, and I'm aware of the courses that I'm going to have to take in the future if I continue my computer science degree. And I'm also pretty much self-taught with a lot of the other development skills that I have. I started to learn to program well before I was in university, and a lot of what I know I didn't learn in university, so I gotta have a decent perspective here as someone who's been through school, but also teaches himself a lot of programming. Anyways, with that said, I will lastly mention here that there is a reason why a lot of developers don't learn these topics. Again, I'm not trying to say you need to go out and learn them. A lot of them are relatively useful in a real job environment. However, I believe it's important to be aware of some gaps in your knowledge, and hopefully this video will just show you some things that maybe you haven't considered before and you might want to learn. Anyways, let's go ahead and get started after a quick word from our sponsor. Before we get started, I need to thank the sponsor of this video, which is AlgoExpert. AlgoExpert is the best platform to use when preparing for your software engineering coding interviews and has the highest quality coding interview practice questions. With 160 practice questions, detailed solutions in 9 of the most popular programming languages, a feature-packed browser-based coding environment, extensive test suites, and conceptual overviews and code walkthroughs for each and every problem, AlgoExpert is the best resource to use to ace your coding interviews. AlgoExpert also has a data structures crash course, coding interview assessments, and a mock interviews feature. I can highly recommend AlgoExpert as a former customer myself and now an official instructor on the platform. Get started using AlgoExpert today by clicking the link in the description and using the code TechWithTim for a discount on the platform. Alright, so let's go ahead and dive in. Now, the first thing I'm going to clarify here is that a lot of the main topics I'm going to bring up are just the names of university courses that I've taken. So what I've kind of done is gone and looked through all of the courses that I've taken and that I need to take in the future and thought about if I was a self-taught developer, if I would have learned that content or even like a subset of that content. So if it was a course where this is something pretty important and most developers already know this, I obviously didn't include it here, but if it's something like, say, math, then I probably put it in this list because that's something that as a self-taught developer is not super important, not a real practical skill, and you don't really necessarily need to learn that to get a job. Anyways, let's dive into topic number 1 that self-taught developers most likely will never learn, and that is advanced mathematics and proofs. Now, when I say advanced mathematics, I'm really talking about university level mathematics, and I'll go through kind of the main courses that I'm talking about here. So the first one, this is pretty obvious, but calculus. So personally in university, I had to do calculus 1 and calculus 2. These were actually pretty difficult courses. So in these courses, pretty much what we learned was integrals, derivatives, and a few applications of integrals and derivatives. I haven't found these super useful in computing. In fact, the only time I've ever had to use any of that knowledge is when I was looking at some advanced machine learning kind of explanations. So the math behind some machine learning models or machine learning techniques or artificial intelligence related stuff. But other than that, I've had pretty much no use for calculus in my life since then. Anyways, moving on, the next course that I'm kind of grouping in this advanced mathematics and proof section is going to be linear algebra. Now, this is actually one that I would say is pretty important, not simply because of the content that it teaches, but because of the way it allows you to kind of think about math. So linear algebra is a much different type of math than something like calculus or algebra in general, like regular algebra. With linear algebra, you're doing 3-dimensional math. You're working with matrices, you're working with vector spaces, and just a very abstract field of math that I know to a lot of people who are in my course was very new. And for me, again, I didn't find it crazy useful in my experience writing code or being a software engineer, but it did help me kind of think about math and problems in a different way. And that's why I found some value in it. Moving on, the next 2 courses are ones that I actually hadn't even heard of until I went into university, and this is discrete structures and discrete mathematics. Now, discrete mathematics is kind of the first course, and discrete structures is the second course, and what you learn in this is actually very computer science relevant math. So you're learning about proofs for specific algorithms, you're learning about things like permutations, combinations, graph theory, set theory, modular arithmetic, and really a lot of the underlying math behind a lot of the principles in programming languages that you're using and behind a lot of very famous algorithms that solve problems. So these courses I actually found super useful. I wish I could recite more of what I learned in them, but I'd recommend that if you haven't heard of discrete mathematics or discrete structures, go and give it a Google search, look at some, syllabus or curriculum for it, and just see all of the topics that it covers, because they're pretty interesting. And one of the cool things that's taught in these courses is actually how you prove the correctness of algorithms. So how do you say that my algorithm 100% is going to be correct on any input, and how do you do that using math? That was probably the most interesting aspect, also the most difficult aspect of this course. All right, so with that pretty much wraps up this first section, which is advanced mathematics and proofs. Again, the reason I put it here is because why in the world would you go learn this unless you had to learn it, or you're just a math geek? I know I'm not, and if I wasn't in school, there's no chance I would have learned any of this on my free time. All right, so moving on to the next topic here, I have digital systems and computer architecture. Now, these were two separate courses that I took in university, but I'm kind of clumping them together because digital systems was first and then computer architecture was second. And what was taught in these courses was really how computer hardware works on a much lower level, and specifically how a processor actually works. So how you take, say, two numbers and add them in a computer. So not like, okay, how do we look at two numbers and add them, but how do wires and circuits and electricity actually allow you to perform computations? Now, to me, I found that super fascinating because I'm someone who's really into building computers, and I like the hardware aspect as much as I like the software aspect. And so to actually kind of get an insight into the lower level and be like, oh, this is how, the memory of a computer is managed. This is how I access some data that's at a specific memory address. This is what machine code looks like. And this is how I take, some commands and actually run them on an APU or a CPU. That was really, really fascinating. So other things we learned in these courses was the different gates that you would use in a digital system. So an AND gate, an OR gate, a NOR gate. We learned about Boolean algebra, so how you simplify Boolean expressions, and a ton of other stuff. It's been a long time since I've taken those courses. These were very difficult courses. These were probably some of the hardest courses that I had to take, but the knowledge that I learned in them was really valuable, and I'm actually really glad that I got to take them, because even though they were a pain in the ass back then, right now I feel like I have a much, much better understanding of how a computer works as a whole, not just at the software and the code level, but actually on the lower level hardware level, which is something that I like. All right, so moving on to the next topic, we have programming paradigms. Now, programming paradigms refers to the different styles of programming, and every programming language that you write in implements specific programming paradigms. So for example, a language like Java, this is an object-oriented programming language. That's its paradigm, it implements that. Whereas a language like Python implements both functional programming and object-oriented programming, and I think it implements something else as well, but those are the two ones that I know for sure that it implements. Anyways, the point is that most developers only ever learn a few programming languages, and most of those programming languages are the same paradigm. So if you're learning languages like Java, JavaScript, Python, C++, these all fit into kind of the similar or same paradigm, and you're writing code in a very similar style. The way you solve a problem in Python is very similar to the way you solve it in Java. The only difference is the syntax might change a bit. There might be a few language features that kind of differ across the problems that you're solving. Point being, there's a bunch of other programming language paradigms as well that most programmers never look at. For example, imperative, logical, procedural. There's a bunch of other ones that I can't remember off of the top of my head, but the way you write code in these languages is completely different from the way you write them in your kind of traditional modern languages. Now, do you really need to know these paradigms? Probably not. They're probably not going to be useful to you in your job. But for me, when I had to write code in, say, an imperative style, I actually became a better programmer because I had to stop relying on a lot of the kind of language features I had in a language like Python and really think hard about how I'm going to use the bare minimum amount of features to solve this problem. For example, I had to work in a language called OCaml. Now, I'm not very knowledgeable on OCaml. It's just what I did in the course. But when we were in the course, we were never introduced to a loop. So there was no for loop or while loop or anything like that. If we wanted to loop over something, we needed to use recursion. So we had to have a recursive function if we just wanted to say, look at every element of a list. We had all kinds of nested functions, higher order functions, and all kinds of crazy random stuff I'm actually going to talk about in the next section. But the point is, go and look up programming paradigms and look at some of the paradigms you've never seen before and just have a look at those languages because they're very cool. And if you can learn even just a tiny bit of a different paradigm, in my opinion, it makes you a better programmer and gives you kind of an appreciation for a lot of the features that you might use in your modern programming language that you just, assume are always going to be there. Anyways, let's move on to the next topic. All right, so moving on to the next topic, I have programming language concepts. Now, this was a specific course that I took in university as well. This is the one that I had to write OCaml code in, as I was mentioning in the previous section. And in this course, we learned some very advanced programming language concepts. And when I say that, I literally am talking about the different ways in which programming languages are implemented, how, memory is handled, how execution occurs in a language, and a lot of very low-level things. Also, how to create, multiple threads, distributed programming, multiprocessing, multi-threading. A lot of stuff like that was taught in this course. And one of the cooler things that we learned was higher order programming and higher order functions, which means having, a bunch of nested functions inside of each other. We're having a function that returns another function. And then we're talking about things like closures. And I'm just rattling off a ton of things that I remember learning in this course. The point being, this course actually taught us about the design of a programming language as a whole, and how you pick what features should be in a programming language and what kind of pros and cons you get, or what, advantages and drawbacks you get from different implementations of programming language features. So I feel like I'm just completely rambling in this section. Again, I don't remember a ton of this stuff. I learned this a while ago, but this was something that I learned in university that I thought was useful and worth a mention in this video. Anyways, let's move on to the next topic. All right, so the next and last topic I have on my list for you here is operating systems. Now, when I say operating systems, I'm not just talking about, Linux, Mac, Windows. That's not what I'm referring to. I'm referring to how operating systems actually work on a lower level. Now, full disclosure, this is a course that I have not taken. I actually stopped school. I'm kind of on a break right now from school. I may or may not go back. That's a different video. Point being, this is a course I haven't taken, so I just went and read kind of like the syllabus for this course and picked out some of the key points so that I could discuss them with you, because this is something that I really know nothing about. Anyways, operating systems, something that most self-taught developers, including myself, probably will never learn. So when I say that, I'm talking about things like process management, process scheduling, concurrency, CPU scheduling, memory management, virtual memory, mask storage systems, file systems, input-output devices. How does an operating system work with all of this stuff? What actually is an operating system? How do you build a basic operating system? Those are all things that, to my knowledge, are taught in this course, and I'm not going to elaborate on them more because I really don't know what I'm talking about in this section. Point being, most self-taught developers don't learn this. So with that said, I actually am going to end the video here. I hope that this was somewhat insightful and at least maybe gave you some topics to consider learning. Personally, I find learning anything like this is going to give you some value. You can question how much value it is and if you should learn it or not. But for me, I don't regret taking any of these courses, even though at the time they were a lot of work and a pain in the ass, as I said previously. But now, after taking them, I do have an appreciation for all of the stuff that was taught there, and I'm grateful that I was able to have the opportunity to learn them. Anyways, I hope you guys enjoyed the video. If you did, make sure to leave a like, subscribe to the channel, and I will see you in another one.